Yeah, let's throw a random equation up there. Let's go like f of x equals like the square root of x like plus 1 or something like that. Now, I know we've talked a little bit before whether or not that's going to be a function. The easiest way to tell if something is a function is a vertical line test. Once again, if you're thinking, if I plug in a number for x, I want to get one output back. If I get more than one, then it would not be a function. Okay. So always check kind of real quick. Typically, we're going to look at a graph and see if it passes. Most of what we're going to deal with in here is going to be a function. So that's all great. The big dog, I think, is going to be the domain. And I know we've talked about that a little bit before, but I can't square a negative number. And so I have to think about making the inside of that radical positive, or maybe 0. So we're going to set the inside greater than or equal to 0. And so that means it would be all real numbers greater than or equal to -1 if I solve that, right? So I can plug in any number I want bigger than -1. And equal to -1. So I can plug in a 0, a 1, 2, 3. I'll get a number back for all of those. The range is all the possible outputs, all the numbers that I'll get back if I plug those numbers in, right? Well, if I think about numbers I'm plugging in, I plug in a -1, I get 0, square root of 0 is 0. If I plug in like a 0 in there, I get a 1, that's a positive number. Plug in a 4, I would get square root of 5, that's a positive number. I feel like I'm getting all positive numbers. Sometimes the range is a little easier to see on a graph. So I would graph it, and then that helps me see like what that would be. So rough sketch of this graph. Do you guys remember what this graph kind of looks like? Square root? Yeah, it kind of looks like the symbol. Looks like the little, it kind of looks like that symbol right there a little bit, right? And then we kind of have some shifts. We might talk about those shifts a little bit more in detail later, but that graph would look something like this. And we can throw that on our graphing calculator. So I'm going to demo that just real quick. I know you guys don't have one yet, and that's totally fine, but this is how you would graph it on our graphing calculator. So we would hit the top left button that says y equals, and then you type in your function. So this would be square root. For our x variable, we're always going to use this xt theta n button. That's our main variable button on our calculator. So we're going to use that one right there, x plus 1. Like so, and then if you hit this little graph button, it should graph it for you. So that looks like, well, kind of like, this is ballpark, this is close. Anyways, so that's pretty good. That's what that graph would roughly look like. Plug in a 0, I get 1. Yeah, plug in a -1, I get 0. Plug in probably a 3, I get 1, because, square root of 4 is, 2. Plug in a 3, I get 2. I caught it, but I knew you guys were thinking it. I knew you guys, see, you got to yell at me, and then I got to bump that up to a lucky number 7, but we're still at 6, so okay, sweet. All right, so the range and the domain, I can look at the graph and think about what that domain and range is going to be. The domain is how far left and right this graph goes. So is it, all right, well, what are my possible values going this direction? What are my possible values going this direction? Well, it looks like the graph kind of stops right there. It kind of runs out of steam, right? And so as far as left and right goes, it looks like -1 is as far left as I'm going to go. And then I go as far right as I want. Well, that's my domain. All real numbers greater than or equal to -1. Okay, so I think about left and right for domain, my possible x values. My range is kind of the opposite. It's like, well, how far up does it go? And how far down does it go, right? Does it have like a floor or a ceiling kind of idea, right? Well, this definitely has a floor. Looks like the lowest it goes is like right there at a height of 0. And then looks like it goes up forever. I know it kind of, is a little bit lame and maybe doesn't climb very fast, but technically it's climbing. Technically it's going up there. If I plugged in a million, square root of a million is still a pretty big number, right? So it's still climbing. It's still going up in that direction. All right, cool. So let me take this off. So the range for this one, the up and down, would be all real numbers greater than or equal to 0. So I'm not going to get anything below that 0 for the range on this one, okay? Now, some people would argue, like, well, wait a second. I see a square root, right? Square root of x plus 1. Aren't I supposed to do like plus or minus or something like that? Like when I square root? If the square root is already there, it's just whatever the sign is that's with it. So there is no sign there. Technically, this is just the positive version of it if the root's already there. If you're square rooting both sides, that's when you do the plus or minus business. Besides, if I did plus and minus, like right there, that would be this graph like this. And then that wouldn't be a function, right? So, okay, good. Cool. Man, can you guys hear my computer? It's like overheating. I think it's the graph. This program, my computer is, Anyways, all right, cool. So are we doing okay with that? Is that making sense so far? So domain range, is it a function vertical line test? How far left and right does the graph go? How far up and down does it go? Hopefully we're happy with that. So the next big key feature we want to take a look at for graphs is where is the graph increasing? Where is the graph decreasing? I might turn this off for a second. I kind of want to go back and do one more thing, but I'm going to turn it off for just a moment. Sorry, let my computer literally breathe. That's insane. Decreasing and constant. Sorry, so constant. Okay, so these are not the things that you can see. Okay, these are the three kind of main features of flow for a graph. So how is this graph flowing? How is it, what is the general trend? Is it, I think of it this way. If I'm reading a graph, just like we read a book, we go left to right. So we want X to increase as we move left to right. If the graph is increasing, it means that it's going uphill is what that really means. If the graph is decreasing as I go left to right, that means the graph is going downhill. And if the graph is constant, that means, well, it's not changing height. It's going to kind of go like a flat direction like so. Okay? All right, sweet. So today's a little more like intuitive idea of it, I hope. We're going to get more into the mathy formal definition when we get into calculus. So that's on the way. But how I think about increasing, this is the way that in my brain, think about it. So as X moves right, so as we go from left to right, y, or f of x, maybe I should write f of x, moves up. Okay, so as x moves to the right, my y value, f of x, moves up. That means the graph would be climbing as I'm moving from left to right. If I'm decreasing, it's kind of the same like beginning. As x moves right, we always want that to move to the right. For increase, decrease, my f of x should move down. And then the last one, constant. As x moves right, f of x, remains constant. Well, I can't use the word in the definition. That'd be dumb, right? You ever do that? Look in the dictionary and they use like a synonym of the word, or they use another word that you don't know, and then you go look that word up and it's got the original word in there and you're like, what's happening here? Remains the same. All right, cool. So we want that to be like a flat line, basically, right? So as we move to the right, we want no change in that f of x. We want it to go up and down. Now, what I do want you to wrap your brain around a little bit for increase, decrease is we do have movement, right? As we move left to right, what is that y value doing? Not just is it positive, is it negative? I want to know as I'm going in that direction, that motion, is the motion going up or is the motion going down? Or of course, flat. Okay? So when we write answers, a couple kind of key things for this. Whenever we talk about increase, decrease, constant, we're always going to refer to the x values. So we're always going to use the x values as like our markers for where it's going to maybe switch from one to the other. We're going to use interval notation to write our answers, which kind of sucks because it looks like ordered pairs. But now we know function notation, so we're good. And then there was one more thing. But anyways, as I just draw a rough, so let me just throw a graph up here. Let's say I had a graph and it was like 1, 2, and then 1, 2, 3, 4, 5, 6. That looks pretty good. That's far enough. We don't need to go any further than that. And let's make a cool looking graph. Let's see. I feel like we should do a flat line here. And then maybe I'm going to do like a parabola-ish thing here. And then maybe I'm going to do, just a linear function climb like right here. And then maybe here. And then flat. Okay, that looks pretty good. It's a crazy piecewise function. It's got a bunch of EKG looking things that would be pretty good. All right, so if I were to label this, if I were to think about where this graph is going, uphill, downhill, or flat. It looks like as I start, this is going to be constant. So it like remains at a flat line right there. That would be the constant zone for it. It goes downhill right after I hit this first spot right here of 0. And so I'm going to put decreasing right there. So I'm just going to throw a little D on there. I know it's going downhill for that little part. Okay. And then I switch back to increasing. So it's going uphill for a little zone, and then I go back to decreasing, and then I go back to constant, right? So I want to label these X values as my intervals, right? So the X value is where I'm really concerned about where this is going to change or switch, okay? So looks like I've got to switch like right here. Actually, let me, we're going to change colors. What, red? Let's go red. I heard you're not supposed to teach in red because teachers grade in red, and so everything you do wrong is in red, and then you're like, oh, Gumke's lying to me right now because he's writing in red. Isn't it funny how our brains associate? Okay, anyways. All right, so those are the X values where this kind of switches, where this changes from one to the other. So if I were to look at my zones right there, like where this is increasing, decreasing, or constant, let me just write increasing down here. So I'm going to use interval notation for my X values to say where this is increasing. So I'm increasing from, looks like +2 to +4, right? Now, I don't care what the height is. That doesn't really matter. I just want to know where is it making its transitions. And so from 2 to 4, that's where this is increasing. And we're going to use interval notation. Now, we can choose, of course, soft brackets or square brackets. For these intervals, since we're moving, since we have motion, we're always going to use soft brackets. We don't want to include the endpoints. The endpoints, it's like the transition. So it's kind of like both or neither. And so since we're not sure, we're just going to leave it out. And by doing that, we'll just use the soft bracket. So any number between 2 and 4 as it travels, this would be increasing. Okay? Decreasing. Decreasing is where it's going downhill. Well, X value, it starts at 0. I know it's up at a height of like 1 or 2 or something, but it goes from 0 to 2 for decreasing. So 0 to 2 like so. Okay, and then of course it goes back increasing. And then it looks like from 4 to 5, it's also going downhill. So I'm going to use a little and symbol, a little union symbol, and we're going to go 4 to 5. And so we're feeling pretty good about that. And then our constant zone. So anywhere where it's flat. So it looks like it starts at -2 and goes to 0 for its constant zone. And then looks like from, 5 to 6? I think that sounds about right. Like so. All right, cool. Are we good with that? Is that making sense? That's where the graph's going uphill, downhill. Our calculators don't do a great job of giving us these movement intervals. It's really good at finding order pairs, at finding out like one location. It doesn't do great on the motion. I will say that. So increase, decrease. We just have to look at a graph, interpret that, and try to write our intervals for that. Now, if I had that exact same graph, but I moved it. Let me pick a different color. Let's go like purple. If I had this graph right here, that would be the exact same answer, right? We would still use the X values for it. I don't care how far up and down this graph is. We're just going to use the X values. So the heights don't really matter like exactly what they are. We're labeling all of those as X values. So that's kind of key. Just put a little star down here. All X values for your intervals. Okay, so always they're going to use X values for those intervals. Are we doing okay? Is that making sense? So where it's going uphill, flat, downhill, hope we're good. So, all right, sweet. So the next big thing that we're going to talk about is, let me go ahead and sneak this up here, would be what they call relative maximum and minimums. And you've probably talked about these before. We're going to spend a ton of time in calculus talking about relative max, relative mins, using calculus to justify those answers, seeing what that'll look like. So I just want to get a kind of an intuition on how do we find these relative max and relative mins and what they're going to look like. So let me just throw a graph up here. Let's just say I had a graph that was like, I don't know, this looks pretty good. That looks nice. This kind of looks like a mountain range or something. Yeah, sure, that's pretty good. All right, so if I'm talking about relative max or relative mins, max and mins mean like high spots and low spots, right? And I'm sure you've tired of looking at COVID graphs that have like the big hit at the beginning, and then we're winning, and then we're losing, and then we're winning, and then we're kind of going to these like little relative bubbles, if you will, right? So as I look at a graph, anywhere where I'm at the top of a mountain, we're going to call that a relative max. So they call it relative because there might be higher points than it, right? You look at the stock market, there might be a high point here, but maybe it like fell and then it came back up and is at a relative high spot in that little zone, right? So I think of these like kind of like horse blinders. So I'm like, all right, I'm just going to zone in on like one spot right here. And so I would say that this high spot right here would be a relative maximum. Basically the top of a peak. You got like Mount Spokane, and then what's the second mountain? Is like Kit Carson? Isn't it Mount Carson? I feel like, isn't it Kit Carson? I don't know. I've only lived here forever. Anyways, multiple mountain ranges, right? We might have the big dog mountain, Mount Spokane. We might have like some of these little satellite mountains, these smaller ones. But they're still relative max if you just looked at their little zone right there. And anyway, so that would be a relative max. This one right here is also a relative max. So it's at like anytime you have the top of a mountain. And then anytime you have like a reverse mountain, like, I don't know, if you flipped your head over and it was a mountain like upside down, or a valley, that's probably the name of. Okay, so anytime you have like the bottom of a valley right here, this would be a relative minimum. And so I'm kind of once again thinking relative, like relative to a zone. So I might like kind of think, well, from here to here, there's a high spot in between those two. And I know there's a higher spot. But if I just kind of zone in on one spot, that they call a relative, they call these relative extrema, extreme values of the graph. So anyway, so relative max mins, it's just top of mountains, bottom of the valleys. Relative max mins cannot happen, just so you guys know, at the endpoints. Okay, so these endpoints right here, they're not relative max nor relative mins. I know it might look like it's at the bottom of a valley, right? And like the one on the end right there, I just kind of put a question mark and maybe a question mark. Those can't be relative max mins at endpoints because, well, I don't know what it's going to do after that. Is it going to go like this, or is it going to go like this? Well, or maybe it's going to go like this. I don't really know, right? So since in the end, I can't say definitively that's like the bottom, right? It could keep going, and then it wouldn't be a relative max or a relative min. Now, a little bit more like mathy in this. For you to have a relative max, we have to go from an increasing zone to a decreasing zone. Okay, so we have to make that switch. That's what creates or defines a relative max. Climbing the mountain and then coming down the backside of the mountain, right? That would be a relative max for that. And then, of course, vice versa for a relative min. We have to switch from decreasing to increasing to have a relative min. So we want those switches to happen, those changes on it. Okay, second relative max. This went back to decreasing. Since I made that switch, I'm good to go. Okay, switching to a constant does nothing. It's got to be increase, decrease, or decrease, increase. If this like kept going constant right there, that point wouldn't have been a relative max nor a relative min. Okay, so a relative max, if I were to just kind of write it like so, relative max, you have to go from increasing to decreasing. It's got to switch that way. You got to climb the mountain and then drop down the mountain, right? If you're doing a relative min, we have to be going down the mountain and then climb back up the mountain. So that would be decrease to increase. Okay, and we're going to come back and backfill all this with some calculus, but this is just kind of the key vocab words. I'm going to say these a bajillion times in this class. So I just want to make sure we're used to the words that I'll be saying, and hopefully we're good. Man, my iPad still says 9:41 a.m. I don't know why it says 9:41 a.m. Is it 9:41? No, it says 9:41 all day. Literally all day. Anyways, I think it's the program. We're going to blame the program for this one. That's my. Okay, let me give you a function. I'm going to do this on the graphing calculator, so I might as well push start on this while I'm thinking about it. I will do a rough sketch on the side, so if you don't have one, it's totally cool. You'll still have like the picture in your notes, and we'll be fine. But let's go ahead and take a look at a function, f of x. Let's do x to the third minus 12x. Let's say that was our function. I know you can't see it, but let's do that one right there. And so I've got a function. I want to find out, all right, where's this graph increasing? Well, first off, is it a function? Yes. Domain, range, that's all stuff we can kind of easily, I think, check out at this point, I hope. Is it increasing, decreasing, constant? Does it have any relative max, relative mins? Those are going to be kind of the key features they're going to have us find. So yes, I'm going to cheat and use a graphing calculator. However, I am going to cut. Whoa, that was a terrible line. I am going to copy it like over here, just so we, have it in our sweet notes. All right, so if I were to graph this, once again, I'm going to go y equals. You can clear out all that junk that's already there. Let's do x raised to the third. The raise button is this caret button. I'm sure you guys have seen that before. I don't know why it's called a caret. I guess it kind of looks kind of like a carrot. Maybe. Anyways. And then minus 12x. I think that's it. Okay, and then we're going to hit graph, and then be good. Sometimes not all graphs fit in the graph, fit in the little, there's a name for window. Yeah, the window of there's a button right here that says window. And so we're going to mess with that button a little bit. The top 5 buttons, there's kind of a reason that they put them on top and because we're probably going to use them a lot, right? So anyways, when in doubt, it's probably in that top row. There are a couple other buttons we're going to use a lot. This math button's got a lot. Well, it says math, so it's got to be important, right? But that top row is going to be pretty huge for graphing calculator. So if you want to change your window on this one, it looks like it just needs to go a little higher and a little lower, right? So if I hit the window right here, this gives me all of my scale, or all of my window size, if you will. So by default, it's going to go from -10 to 10. That's always the default for the X. And for the Y, it's going to be -10 to 10. So definitely the default. The X scale is how often it puts a tick mark. So if you go from -100 to 100 and you leave it at 1, it's going to be like solid tick marks all the way across. Anyways, so I'm going to change this. I'm going to change my Y min and max. Let's go ahead and change this to, I don't know, like a 20 and then like a 20. Like so. So that's going to bump up the window left and right. So I want you to get a little bit comfortable changing your window and seeing what it looks like. All right, so there's my graph. Looks something like that with my adjusted window. So let's go ahead and just draw that in here. All right, that looks pretty nice. Okay, so kind of the typical rap sheet questions they're going to ask you. Is it a function? Yeah, pass the vertical line test. Is it the domain? Domain, it looks like left and right forever. So I'd say domain is all real numbers. Range, it goes up and down forever. So all real numbers. And then the other big key features. Where is it increasing? Where is it decreasing? And then where is it constant? So we're going to look at those little zones. So if I went here, I think it looks like it's increasing right here, decreasing on this zone, and then increasing right here. So that's kind of the chunks. And I think it switches at these relative max and relative min spots. So I see this as my relative max, and this is my relative min. Okay, so that's the relative max and min for this one. What's up?
Is there like an equation or something to find the relative max and min?
There is. Don't tell anybody I'm showing you this. Oh, that's going to be a 2. I'm smiling underneath my mask. I know you can't see that. Yes, there's an equation. Calculus is going to solve all those, and we're going to get there, which is soon enough, but we're on the way. Okay, anyway, so for now, I got my typical stuff, but our calculator will actually find the relative max mins for us, that's fantastic, right? That's even better maybe than that crazy stuff I just did, but hang tight. So let's go ahead and look on our calculator. Now, our calculator has this button right here. It's kind of hard to see, actually. So it's right above the trace button. It says calc. That stands for calculate. That's where you're going to calculate a lot of your stuff. That's actually, if there's one menu that AP really wants you to know, is how to do everything in that menu right there. Good news is there's not that many things in there. There's only 7. And the first 4 are not even calculus really. A value, that's ordered pair. 0, it finds the zeros. We're going to go over all how to do them. Min and max, I like to start with these because, once you know these, then you can pretty much do the others. Intersect, it's where 2 graphs cross. Dy, dx, I feel like we've seen that before, like change in y over the change in x. Like y2 minus y1 over x. Oh, okay, that's going to probably be some kind of slope thing. And then, oh, this is kind of weird. I have no idea what that, well, I know. You guys have no idea what that means, except for it's got a cool symbol right there in front. I feel like that symbol we've seen before. Maybe. Oh, okay. Mine just might be the script version of that. Anyway, all right, we'll come back. Okay, so if I want to find a relative max, okay, basically your calculator needs the horse blinders. It needs to know where's the zone that you want it to look at to find a relative max point. So let's go and do number 4 first. Let's find that relative max. So you can just hit the number, or like on the thing, or you can scroll down and hit enter. I just like shortcutting the number. Now, it's going to ask you for the left bound. It's basically saying, what is the left side of your interval? And so you can just scroll on the left side. Anywhere on the left is good. It looks, I don't know, that's about right. It doesn't have to be perfect. You can come all the way down here. It doesn't really matter. So hit enter, and it'll give you the left bound, essentially, the left blinder, okay? Then it says get on the right side. So we're just going to scroll onto the right side and hit enter. I say somewhere in between there, I'm going to have a relative max, a high spot, if you will. And then it asks you to guess. Usually you don't have to guess because, well, if you pick good left and right, the guess is for if you picked ones that has multiple in it, and then the guess tells you it'll find the closest one to the guess. But pick a good window, and then you usually don't have to guess. Anyways, just hit enter on the guess, and it should tell you what the max is. It looks like it's at -2 and 16, which all my crazy math, I kind of got that same thing, right? So I think my relative max for this one is going to be the order pair f of -2, 16, right? So that's where that relative max happened, okay? We could probably use a little bit of symmetry and see what the other is, but I do want to just do the relative min as well. So let's go ahead and sneak that in here. The relative min for this one would be f of something equals something. Let's go ahead and find that ordered pair. So I'm going to use my calculator. I'm going to go to the calculate screen. That's a big dog one for us. Number 3 on there is the minimum. The left side, you can also just manually put in your numbers. So if you think it's at 2, maybe you're going to pick like 1, enter, and then maybe like 4 and enter. And then it's somewhere in between those. The guess, you don't have to guess, so just hit enter. And it tells me it's at 2.000014, -6. Okay, so the calculator's not perfect, but we can see that that's probably about 2, right? I mean, if I gave you $2 and 14 millionths of a cent, you'd be like, thanks for the $2. I said, you're welcome. Anyways, so at 2, we're at -16. That would be the relative min for this one. Okay? All right, cool. So by knowing those relative max mins, I also kind of have the built-in like increasing and decreasing zones, right? I've already got like those figured out. Increasing looks like right here it goes to -2. Remember, always use x values for increasing. And then, so I'm going to say from -infinity to -2, this graph is increasing. And I think the other max right here was at +2. So we're going to go and 2 to infinity and beyond. And then, of course, the decreasing zone, right? Decreasing zone was like all of this little part right here. I need colors that are more farther apart. Me being colorblind, this is not helping. Like, I totally drew that, and it was the same thing. Sorry. I'll fix that later. All right, so decreasing from -2 to +2. Once again, those are all x values, right? We're talking intervals for increase, decrease, and so, yeah, those would be the x values for it. Okay? All right, are we doing okay? Okay, cool. So the last thing, just real quick talk about is how we graph piecewise functions. Our graphing calculators are terrible at piecewise functions. It takes so much work and so much type in. It's honestly just not worth trying to graph a piecewise function on your graphing calculator. So there'll be some that we want to do kind of by hand. So I'm going to shut that off because my computer is going to probably die if I don't. Oops. There we go. So let's go ahead and graph just one piecewise function. So let's give you a function, f of x. And remember, piecewise was the ones that had the kind of the weird brackets. And then we got some equations to throw up here. So let's say I did like x plus 1. And let's say I did 3. And then let's do like 4 minus x or something like that. Okay, so I've got 3 different graphs here. I'm going to keep most of it today at linear, so I think you guys know how to graph linear equations, but how to work this in a piecewise function. So let's say x is less than 0 for that first part. And then let's say we're going to go from 0 less than or equal to x less than or equal to 2. And then let's go x greater than 2 on this one. All right, so let's say we were to graph this piecewise function. So remember, the stuff on the right here, this is all your domain, right? So this is telling you like what you can plug in where. So if I want to find f of 5, I have to plug it into the bottom equation, right? Because that works for that bottom domain. If I want to find f of negative 100, got to use the top equation. If I want to find f of 1, well, what's f of 1? It's a little weird. Well, 1 works for the middle equation. Plug a 1 in for the, but there's no x to plug it in for. So what would that be? If I plugged in a 1, what would you get back? You just get 3, right? You get 3 back all the time, no matter what. Oh, wait a second. What's the graph of that look like? What's the graph of y equals 3 look like? It's a flat line to 3, exactly, right? So any x value I pick between 0 and 2 will have a height of 3, right? All right, so this is what my piecewise graph would look like if I just did a rough sketch of this. So any number less than 0, I'm going to graph x plus 1. So I'm just thinking in my head, all right, my y-intercept is 1. And my slope is 1. So y-intercept of 1, let's say, is right about there. And then my slope is 1. So I would graph like that. Maybe don't draw that quite yet. The problem is I only want that where it's less than 0. So I only want it like on the left side of that axis. So I gotta tweak that a little bit, right? So I'm gonna go just to the left side of 0. So I only want this part of that graph, right? Just where it's left. Also, I know you guys probably learned this in previous years, but there's no equal sign right there. And so I'm going to put an open circle on the end of that. That means I can get really close to it, but I can't actually get that value. We're going to spend a lot of time looking at those crazy things. And then from 0 to 2. So if I go from 0 out here to x equals 2, I'm going to have a flat line at 3. So I would go up to 3. And that would be that flat line right there at 3. Okay, open circle, closed circle. They're both equal, so they would both have solid points. Maybe. There we go. Good enough. Kind of. That's the one thing I got to figure out is it likes to do this select all business. We'll mess with that. Anyways, it still passes that vertical line test. If I drew a vertical line, I've got an open circle and a closed circle, and so that's just 1 point still, so we're still good. And then let's see, 4 minus x. So I know, just in my head, that's going to be an intercept of 4, so that's way up here somewhere, and then it's a slope of negative 1. So really it's that line right there, but I don't want the whole shebang. I just want it where it's to the right of 2. So I know this is kind of cheating a little bit, so don't tell anybody. We're kind of fake cheating here. 2 is where it switches. So what I want to do is I want to figure out what's the height of 2. Technically, I'm not allowed to plug it in, but I'm going to plug it in. If I plug in a 2 right there for x, I get 2 back, right? So I know that this graph, the whole, is going to be at a height of 2, right? So really, it's the ordered pair that's there, but I'm going to go open circle and say get close to that. Slope is negative 1, and so I'm going to graph a negative 1 slope. It would look something like that. Okay, so that would be my piecewise function. If I were thinking about, all right, is it a function? Yes, pass the vertical line test. The domain and range, it looks like it goes left and right forever, so domain's all real numbers. The range is the up and down. Well, it looks like 3 is the highest it goes, and looks like almost everything below. Although I don't think I'm going to get any numbers between 2 and 3, so that's a little weird. So it's probably going to be less than 2 and include 3. That'll be weird to write. And then, of course, you got intervals of increase, decrease. This would be increasing. This would be constant. This would be decreasing like so. So we could write those intervals, if you will. And then I don't think I have any relative max or mins on this. There's nowhere where it switches from increase, decrease, or vice versa. So anyways, your homework / classwork. Gosh, I didn't mean to take up that much time, is on Google Classroom. So feel free to check out Google Classroom, and the book should be scanned there. And hope you guys have